Hi there, I'm Micaela Kaplan, the ML Evangelist at HumanSignal, and this is In the Loop, the series where we help you stay in the loop with all things data science and AI. On today's In the Loop, we're going to talk about the Model Context Protocol. Let's get started. The Model Context Protocol, or MCP, was open sourced by Anthropic in November of 2024. In short, the MCP is a way of connecting an LLM to tools or knowledge bases in such a way that the LLM can execute actions against those systems. The MCP is a protocol, which means that it is a way of standardizing the inputs and outputs so the system can be compatible with a broad variety of LLMs and a broad variety of tools. Think about how large language models work. We know that LLMs are trained on very large datasets, often the whole of the internet, which provide them with a lot of knowledge about the world, but they have very little access to non-public data like customer interactions. In order for these models to be helpful in those situations, we need to connect them to our personal data sources. We can take this problem one step further. LLMs, as they exist out of the box today, cannot take any action on your behalf, even if they know how to take that action in theory. The MCP helps to add context about the world and how to interact with it to an LLM, thus the context part of the name. The MCP guarantees a certain input from your model to the system and a certain output from your system to the model, such that no matter what you're doing on the back end, the system can understand. Think of it kind of like a USB-C connector, a standardized way of connecting two pieces of technology without regard for what else may need to happen within that technology. Up until the MCP, supplying an LLM with additional context in the form of data or how to take an action meant writing a custom integration that was often disjointed from other applications while also duplicating many of the efforts needed to create the integrations. The MCP standardizes these connections, allowing for modular reuse of code, thus eliminating the duplicated effort. It also enables these servers to connect to many other AI systems using a standard protocol, eliminating the so-called N times M problem, which happens when a large number of client applications need to interact with a large number of servers and tools. According to the documentation, at its core, the MCP uses a client-server architecture. This means that there are a few key parts to the system. First, the MCP host, which is the interface through which you coordinate the interactions between the LLM and the tools. It's where your response is provided. For example, Cursor, Cloud Desktop, or an IDE are all MCP hosts. Then you have the MCP clients, which are protocol clients or instantiations of a server connection that maintain one-to-one connections with a server. Finally, you have the MCP servers themselves, which expose certain functionality to the MCP host through the standardized Model Context Protocol. These MCP servers can connect to local data servers, like your local machine, or external tools and applications using APIs. There are three fundamental primitives that the MCP standardizes that allows for seamless integration between the LLMs and third-party tools. First, you have prompts, which are user-controlled templates or instructions that guide an LLM interaction. Then you have resources, which are app-controlled contextualized data managed by the client, like file context or Git history. These act like REST API GET requests. Finally, you have tools, which are model-controlled functions that allow the LLM to take action, like file writing or an API request. These act like REST API post requests. Anthropic created a number of SDKs in different languages for quick and easy development of an MCP server. With the Python SDK, you can declare your implementations of the three fundamental primitives for your server using a decorator, minimizing the amount of boilerplate code you need to implement on your own. Let's review what we learned today. The MCP provides a standardized way for LLMs to interact with third-party tools and data sources using a client-server architecture that makes your agents more powerful than they were before. The standardization of the implementation gets rid of the duplicate work often required for building these integrations, while simultaneously making the integrations easier to use with other AI tools. Are you building a cool MCP server? Let us know in the comments. That's all for this week. Thanks for staying in the loop. Want even more In the Loop? Check out our other videos. Don't forget to like and subscribe to stay in the loop.